So today we are going to perform the experiment on conductometry. This is our second experiment. The name of the experiment is to determine the solubility and solubility product of sparingly soluble salt barium sulfate. To determine the solubility and solubility product of barium sulfate or lead sulfate at room temperature conductometrically. Now I have taken in this beaker 1 gram of the sodium, 1 gram of barium sulfate, and now I would like to shake this solution. You can see here the turbid solution is there. The barium sulfate is not soluble in water. It is partly soluble or it is sparingly soluble. So with the help of conductometry or by measuring the conductance of the solution, we have to determine the solubility and solubility product of this barium sulfate. It means how much quantity of barium sulfate is dissolved in 100 ml conductivity water. So we has to determine the solubility of the barium sulfate with the help of the instrument conductometry. So the experiment is conductometry. So what are the requirements for this experiment? So we require saturated solution of barium sulfate. Later on I would like to filter this solution. Then I will get the saturated solution of the barium sulfate. So I would like to filter now this solution, barium sulfate. So now the filtration process is going on and the barium sulfate get filtered. So we should have to get the clear solution of the barium sulfate. So you can see in the beaker we get nearly the clear solution or saturated solution of the barium sulfate. Some quantity of the barium sulfate get dissolved in this. So we are getting the saturated solution of the barium sulfate here. Till now the solution it is having some turbidity. It is a saturated solution of the barium sulfate. So barium sulfate it is partly soluble into this solution. Now another requirement it is the 0.1 molar potassium chloride solution. This solution is required for us to determine the cell constant. When we are doing the conductometry experiment, it is necessary to determine the cell constant, because that cell constant value we can use in the calculation. So without cell constant we cannot proceed to determine the specific conductance. So specific conductance it is equal to cell constant multiplied by the conductance. So let us see another requirement, it is distilled water. So we have to measure the conductance of the distilled water also. Before starting the experiment, I would like to standardize the conductometer. So you can see here in the instrument at 2 millimools, it shows approximately the reading here 1.00. So let us adjust this at 1.00. If the instrument shows the reading 1. In the standard condition. So I would like, by moving this knob here, the conductance should be 1.00. So you can see here the conductance is equal to 1.00. Now the conductometer is into the standard condition. Now let us measure the conductance of distilled water. Okay, conductance of distilled water here. So I would like to change this now knob. So conductance of distilled water, it is approximately equal to 0.0. So conductance of distilled water it is 0.0. So distilled water here it does not show any conductance. Okay. Now determination of the cell constant. So I would like to take the solution of the 0.1 molar KCl in this beaker. This is 0.1 molar KCl solution. So approximately 50 ml solution of the potassium chloride is taken here, and I would like to measure the conductance of this solution. So the conductance of the solution it is now, you can see here, the instrument shows some reading here. It is around 12.94. So this is the conductance of 0.1 molar KCl solution. Conductance of 0.1 molar KCl solution. So it is 12.94. It should be multiplied by 10 raised to minus 3. That is the factor. Because the readings are in millimoles, we have to write the readings in moles. So it is 12.94 into 10 raised to minus 3 here. So that is the conductance of the KCl solution. Once again, I would like to withdraw this conductivity cell, and it should be deep in the solution of the water here, conductivity water. Now the second part here, you can see determination of the cell constant we have completed. We measure the conductance of 0.1 normal KCl solution. Now the second part, determination of the solubility product. So to determine the solubility product of barium sulfate it is a sparingly soluble salt. So I have taken 1 gram of barium sulfate powder in a beaker, and I have added 100 ml of the water, and I have shake that solution of the barium sulfate, and I have filtered that solution. So this is the filtrate here. Previously we have filtered the solution. So this is the filtrate of the barium sulfate. Now in that filtered solution, I would like to take 25 ml of that filtered solution in the beaker. Okay, so I would like to take the 25 ml of the solution here. So I want to take here 25 ml of the solution here in the beaker. This is the saturated solution of the barium sulfate, and we want to determine the solubility product of the barium sulfate and solubility of the barium sulfate. So in this beaker I would like to take this 25 ml of the barium sulfate solution. Now I would like to measure the conductance of the barium sulfate. Okay, so barium sulfate it is partly soluble or sparingly soluble in water, but how much quantity of the barium sulfate get dissolved, how much quantity of the barium sulfate gets soluble in water. So I would like to determine the conductance of this solution now here, and with the help of the conductance I can determine the solubility of the barium sulfate. Okay, so now I would like to dip this in the 25 ml of this barium sulfate solution. So you can see here the reading should be equal to 0.16 into 10 raised to minus 3. That is the conductance of that solution. So it is 0.16 into 10 raised to minus 3. So in this way we measure the conductance of the barium sulfate. Okay, conductance of the barium sulfate, and with the help of this conductance I would like to determine the solubility of the barium sulfate. That is the calculation part, solubility of the barium sulfate. So experimental part is completed here. There are 3 readings we have to take. First of all, we have to determine the cell constant with the help of the 0.1 molar KCl solution. Then we have to determine the conductance of the water, because we prepared the solution of the barium sulfate in water, and third, it is the conductance of the barium sulfate solution, saturated barium sulfate solution. Okay, so in the observation table there are 6 columns are given. First, saturated solution barium sulfate, second, conductance, third, specific conductance, then fourth column it is solubility. That formula is given. I would like to show the observation table later on. So experimental part is completed here. Very simple. Just we have to take only one reading. Similarly, we can take another salt also, lead sulfate or any sparingly soluble salt, and we can determine the conductance of that sparingly soluble salt. Okay, so the experiment is very simple. We have completed here the experimental part. Okay, so the conductance of water first, specific conductance of water second, equivalent conductance of barium sulfate at infinite dilution, that value is given. Equivalent conductance of barium sulfate, it is given here, and with the help of these values we can determine the solubility of the barium sulfate. Okay.